Hi, so this video is going to be about finding the distance from a point to a line. This is a somewhat complicated method, but follows a very specific set of steps. So if you can follow the steps, you should be able to get through this with, not too much difficulty. So the important thing to note is that when we're talking about the distance from a point to a line, we're referring to the shortest distance. So the shortest distance from a point to a line meets that line perpendicularly. So you can see in the diagram there that we are meeting that line at a 90-degree angle. So that's important. So you need to kind of train yourself to pay attention to certain words that appear, certain concepts that appear. So when I see the word perpendicular, I immediately think about lines that are perpendicular and they have inverse slopes, negative reciprocals of one another. So you need to kind of learn to recognize those key words. It's really important and may be useful. So the list of steps that we have here below looks a little daunting at the beginning, I'm not going to lie. So we're going to walk our way through one question, step by step by step, and sort of figure it all out. So our end game here is distance. So again, looking at keywords, when I see distance, I think, oh, I'm going to use that distance formula that we learned about, way back when. So that's going to become a key component. I see perpendicular, so I'm thinking inverse slopes, negative reciprocals of each other. So I'm looking for this point. Point N is what I need to figure out in order to be able to use the distance formula. So N is what I need. So when I have the coordinates of N, that's going to give me everything I need to use the distance formula. Okay, well, how am I going to get N? So N is the point that appears on both lines, on this line PN and also on this original line. So it's where those two lines cross over one another. So if I can figure out what the point is here that exists on both lines, then I've got the coordinates for N, then I can use the distance formula. So the steps are as follows. First, find the gradient of that original line L and the gradient of Pn. Those are perpendicular lines, therefore the slopes will be negative reciprocals. Once I have the gradient of Pn, then I'm going to find the equation of the line Pn. So I have a point, which will be P. I have a slope, point and slope. I can figure out the equation of that line. This is the new piece. So solve simultaneously the original equation L and the new equation for Pn. That's what we haven't done yet. We'll get to that. So then once I've solved simultaneously, I have figured out the coordinates of N. I figured out the point that exists on both lines. And then once I have that, then distance formula, here I come. Okay, so let's slowly walk our way through one question, step by step, and hopefully then you'll see how this sort of all comes together. So here's our question. Find the distance from point P, which is 7, -4, to the line with the equation 2x plus y equals 5. So we have this diagrammed over here. So we're trying to figure out the distance from P to N, and P has this coordinates, and the original line has the equation 2x plus y equals 5. You will always have those two pieces of information or have a way to figure out those two pieces of information. Without those two pieces of information, you cannot figure out the distance between those two. So if it's not explicitly given to you as it is in this question, there will be a way for you to figure it out. Okay, so let's begin. Step 1, find the gradient of line L and the gradient of Pn. So line L has the equation 2x plus y equals 5. So you'll recall when you have the equation written in general form, you can very quickly and easily get the gradient from that equation by looking at the numbers that are the coefficients of x and y. The symbol for my gradient is going to be the opposite symbol that exists in the general form. So it's going to be negative. and then the top will be the coefficient of x, the bottom will be the coefficient of y. So the gradient of line L is -2/1. I'm not going to make that whole number because it doesn't really benefit me at this point. Because the very next thing I have to do is figure out the gradient of Pn, which will be the negative reciprocal of the gradient of line L. So the negative reciprocal of what I just figured out is +1/2. Okay, so gradient of line L, got it from my equation. Gradient of Pn just did the negative reciprocal of the gradient of line L. So that first step is relatively simple, not a lot of math to do there, but you have to know how to be able to get the slope of a line in whatever form it is given to you in, general form or slope-intercept form. Okay, step 2, find the equation of line segment Pn. In order to figure out the equation of a line, I need to know two things. I need to know the slope, which I just figured out in step 1 to be 1/2, and I need to know a point, which I know point P is 7, -4. So once I have those two pieces of information, then I have that sort of menu of methods how to figure out the equation. So I could use the gradient formula. I could use plugging it into slope-intercept form to solve for C. I could use plugging it into general form. You have some choice here, but you need to consider what form you want this to be in. It is most helpful to you if you generate the equation of the line in the same form as was given to you in the question for the other line, because that will be handy for, I believe it's the very next step. So if my original line L was given to me in general form, I'm going to figure out line segment Pn in general form. Okay, so to do that, I am going to use the general form method. So Ax, and this will be minus By equals C, minus because my slope was positive. So then I'm going to insert the 1 next to the x, minus the 2 as the coefficient of y, and then I'm going to do the same thing on the other, but I'm going to plug in the value of x from my coordinate, and I'm going to plug in the value of y from my coordinate, and then I'm going to simplify this. We've got x minus 2y equals 7 plus 8, so x minus 2y equals 15. Okay, so now I have figured out the equation of line segment Pn. Okay, so next step. Next is the one that we haven't done before. Now, if you had me in grade 8, we did do this. We solved simultaneously, and we're going to use a method called elimination. So that might be familiar to you. If it is not, we're going to walk through this, so don't worry. So we need to solve the two equations. So the equation of line L, which was given to us in the question as 2x plus y equals 5. And then we need to solve that with the equation of line segment Pn, which we just figured out from the previous part to be x minus 2y equals 15. Okay, so to solve simultaneously using elimination, we need to set ourselves up a system of equations where one of the variables has the same coefficient but the opposite symbol. So meaning +1, -1, +4, -4. So we can see that we don't have that yet. X in the first equation has a coefficient of 2 and has a coefficient of 1 in the second. So that's neither the same number or with an opposite symbol. And then we look at the y and we see a +1 sitting in front there and a -2 sitting in front of the second equation. So again, not the same number, but that one does have an opposite sign. So if it is not set up automatically for you with the same coefficient in front of one of your variables, you can adjust the equation, and you adjust the equation by multiplying every part of it by the same value. to the end of setting up that same number with an opposite symbol. So if I look at my y values, I see that I at least have a positive and a negative here. So I might target y. You can target x if you wish. It doesn't matter which one you go after. You'll get the same answer if you do it correctly. So I am going to multiply this first equation. I'm going to multiply everything by 2. And that's going to give me 4x plus 2y equals 10. And then I'm not going to adjust anything in the second one. So now you can see I have a system of equations where I have one variable with the same number in front and the opposite symbol. Once I have done that, then I'm going to go ahead and add these equations together. I'm going to stack them up just like they're stacked here, and I'm going to add. So 4x plus x gives me 5x. Positive 2y plus negative 2y eliminates. Therefore, that's the whole purpose of this elimination method, is to eliminate one of the variables, allowing us then to solve. So now I see 5x equals 25. So I'm going to go ahead and divide both of those by 5 to solve this equation, and I find out that x equals 5. So that is the x value of the point that exists on both of these lines. I am solving for point n. That's what I'm after. I'm trying to figure out the one combination of x and y that will satisfy both of these lines, both the original line L and the line going from n to p. So once I have the x component, then I'm going to go ahead and use one of my original equations to solve for the y component. It doesn't matter which one you choose, you will get the same answer if you do it correctly, whether you use the top one or the bottom one. I'm going to use the top one only because there's no coefficient of y, so it'll be a slightly simpler solve. So I'm going to take the value that I just figured out x to be, plug that in where I see x, plus y equals 5, and then I'm going to solve. So 10 plus y equals 5. So then I'm going to subtract 10 from both sides, and I get y equals negative 5. So now that I have solved those two equations simultaneously to figure out the one magical combination of x and y values that will satisfy both of those equations, those are the coordinates of point n. So step 4 is write down the coordinates. So you're just taking what you just figured out from solving this. So my x component, or my x coordinate, is 5. My y coordinate, negative 5. Okay, so now that I've solved point n, the only thing left to do is to figure out the distance in between p and n. So that is the last step. Find the distance Pn using the distance formula. So we just figured out point n to be 5, negative 5, and P is 7, negative 4, given in the question over here on our diagram. So distance formula, so figure out Pn, distance of Pn, square root, and we've got x1 plus minus, my mistake, minus x2 squared plus y1 minus y2 squared. So then I'm going to arbitrarily make this x1, y1, x2, y2. Again, you could just as easily flip those around and do them in the opposite way. Done correctly, you'll get the same answer. So Pn, so now we've got 7 minus 5 squared plus negative 4 minus negative 5 squared. So Pn equals, so we've got 7 minus 5 is 2 squared plus negative 4 minus negative 5, 1 squared. So Pn root 4 plus 1, and we get Pn as root 5. On this, you would not go to a decimal unless you were specifically asked, and I can't even think of a time when you would be specifically asked. So the distance between point P and N, so the shortest distance between a point and this original line is root 5, and if you want to, you can throw in units. Okay, so I know that's a lot. I encourage you to go through that a few times, especially if you haven't seen that elimination method before. It would not hurt to kind of go through that a few times. Make sure you understand where all of the components are coming from. If you follow the steps really carefully, you will get yourself to a final answer. Okay, that's it.